Hi, Matt Williams, Techno Evangelist here. Last week, I spoke at the AWS reInvent conference in Las Vegas. I was on stage with Chris Fuchs from Trek 10.
All right. So you are all in the room for SRV 304S, how Trek 10 uses Datadog's distributed tracing and other tools to improve AWS Lambda projects. My name is Matt Williams, and this is, what's your name?
Chris Fuchs. Thank you, Matt.
And I'll let you introduce yourself.
Sure.
I had created a demo for the presentation, which would allow me to show a few things that I find really special with X-Ray. And we had planned for a few errors to happen during the demo. And guess what? We saw a few problems in the demo. But they weren't quite the problems we planned to see. They were different problems. So in this video, I want to show you what I did wrong and how I fixed it. Now, if you like videos like this, consider hitting the subscribe button below. And if you have any experience with Lambda and notice something else I should have changed, share it with everyone in the comment section. Let me start by telling you about the demo. On the first slide, after we introduced ourselves, I told everyone that I was making a few assumptions. And then I wanted to know if the folks in the audience were using Lambda in production. So I gave them a URL for a single question survey. Are you using Lambda in production? The first few folks that answered the question got the response I expected. They chose yes or no, clicked submit, and then within a second got a pie chart showing the percentage of each answer. Unfortunately, most folks got no feedback, so they kept jamming on the button to get their response heard. I was getting all their responses, but I wasn't updating the chart to show them that I got it. Oops. The demo was created using a pair of Lambda functions written in node.js, along with API Gateway and DynamoDB. When a user hits the button to submit their answer, the first Lambda invokes another, which sends the vote to Dynamo. The second Lambda completes and then returns to the first, which does a scan to collect the records of responses. A related thing that needs responses is this video. If you find the video interesting, please respond correctly by subscribing to the channel. 5% of folks who like these videos subscribe to the channel, but 100% of the really cool people all subscribe. I think you know who you are. Well, back to Dynamo. It looked like submitting the data to Dynamo was working, but retrieving the data was timing out. I used the serverless framework to deploy the Lambda application, and for some reason, I configured the database to use provision throughput option. And then I never thought about it afterward. So you have two options when it comes to setting throughput for DynamoDB. First, you can do provisioned throughput. This tells AWS that you know the throughput the database is going to need, and you pay a set rate for that throughput per hour, regardless of whether you use it or not. If you sustain that rate, it probably is going to be the cheapest route. If you need more, configure auto-scaling. If you don't use auto-scaling, then Dynamo will be throttled. I was getting throttled just when I needed it. I was going to mention the pricing here, but it's different for pretty much every region. The other option is on demand. You pay a fixed rate per million write or read capacity units. If you're using your database a bit less on average, but then burst to higher rates, paying on demand may be better for you. For example, if your regular use is in your home office or hotel room, where you might get one request per 5 minutes, and then there's a 2-minute spike with about 1,000 requests while standing in front of 500 people and getting recorded in a video, that might be a good use for on-demand. You also need to consider what a capacity unit is. It's not only the number of requests, but the throughput. And there are different kinds of reads and writes depending on how consistent you need the result to be. The less consistency you need, the cheaper it gets. Now, I'm fine with standard writes, but if one person sees a pie chart with 500 responses, and the next person sees 503, and the next 499, well, that's fine for my use case. So I don't need quite as many read units for that, though I am writing a minimal amount of data and reading quite a bit, so actually I need more read units. In my serverless.yaml file, I said 5 read units and 10 write units. The write units were fine, but I way underestimated the reads. When I looked at my throttled DynamoDB request, there was an enormous spike when I asked folks for responses. Oops. So here we see how to update the serverless YAML file. Just delete the provision throughput section and replace it with billing mode is pay per request. Provisioned is the default, which is why we didn't need to specify it. Also, in the demo, I started the read before I completed the write. That was something I could only see because of the trace. And the problem was because I had written a promise that spat out the right result, but wasn't really a promise. Everything that needed to happen happened, but in the wrong order. Again, I don't need the results to be super accurate, but that's not what I intended. When I corrected the promise, everything ran in the right order. There is one more critical thing you need to understand at this point. You need to click on any other video to keep the party going. And while you're at it, subscribe to the channel. The number of subscribers has grown so much in the last month, but I'm still waiting for you to subscribe. Well, unless you have. And if you have, I look forward to seeing you again soon. Bye.